Hello viewers, welcome to UN College digital class. Today I am going to discuss about the parsing or parser, which is the second phase of compilation. In this class I am going to discuss about the detail how the parser is working, it is the second phase, and what are the input for the parser and what are the different technology in which way parser is performing the task. Let's start. In this slide it is clearly visible that when you will start a program compilation, the first step is it is taking the lexical analysis or lexical analyzer takes the program and the scanner is performing the scanning, preliminary scanning, then it generates the token, and this is the second phase. In this class we are going to discuss about the second phase. The syntax analysis or parsing is the second phase, that is after lexical analysis. It checks the syntactical structure of the given input. In this particular point, I want to explain one point that, for example, suppose you are saying that Ram is playing. According to the lexical analyzer, it is correct because the job of the lexical analyzer is only to detect the tokens. It cannot detect that two is cannot be placed consecutively, okay. But when it is passed all the token to the second phase, that is lexical analyzer, according to lexical analyzer this sentence is wrong because you cannot place two is consecutively. This is the job of the lexical analyzer. The parser checks whether the given input is in the correct syntax of the language in which the input has been written or not. Actually, when you are saying any sentence, any statement, at that time each statement is scanned or each statement is detected according to the pattern of the grammar. It is the same in case of programming language also. When you are writing a program, the syntax analyzer takes the tokens and it checks whether all the tokens are in the according to the syntax of the grammar, according to the predefined grammar or not. Now, in this slide, I have given one example. Suppose the statement is John ate the chocolate. Okay. Now, according to the syntax analysis phase or syntax analyzer, it takes the whole statement, all the tokens, then it generates, it detects whether it is a noun, whether it is a verb, whether it is a phrase, all this in this phase, and this particular structure is also applicable in case of programming language, and this type of structure is called as parse tree. Actually, a parse tree which is the output, of the parser, it is the graphical representation, it is nothing, it is just a graphical representation. What you are writing, that is understandable for you, but for the system it generates the parse tree according to the predefined grammar, and to generate the parse tree it takes or it follows number of ways or number of approaches. The parser generates the syntax tree by using a derivation process. Okay. According to the derivation process, if the tree is correct according to the predefined syntax, then it is okay and it is passed to the next phase. If it is not according to the syntax, then the parser will generate error. Now, it is visible in the slide, you can see it in the slide that at the first step, suppose you are giving some sort of input, then the parser will generate a syntax tree or the parse tree, then the parse tree is passed for the checking phase. If it is correct, then it will pass to the next phase, and if it is not correct, then error will be generated. In the derivation process, when the parser performs the parsing, it mainly performs two important operations. Okay. For example, suppose you are writing a sentence in the examination, your examination copy, okay, answers it. Then the examiner, when the evaluator will check your copy, at that time the evaluator will check whether the answer is correct according to the predefined format or not. The same process is performed by the parser, and in the parsing process it mainly performs two tasks, those are here. It parses the code and looking for the errors, and it generates, the second one is it generates a parse tree. Now, we will discuss some important concepts which are used in parsing. the most important concept is CFG, context free grammar. Actually, when you are saying something to anybody or when you are saying writing any sentence, at that time you are using a grammar. In the similar way, each programming language use their own grammar, okay, and the parser use a grammar which is called as context free grammar, and on the basis of context free grammar it checks whether all the grammar are okay, whatever you have written as program, all these are according okay or not. Actually, the context free grammar has mainly 4 components. Those are, first one is a set of non-terminals. Non-terminals are syntactic variables. Okay, it means that whatever you can derivate, from where you can derivate, all are non-terminals. Then the second point is terminals, which we may say that all are tokens, and these are the basic symbols from which the strings are formed. Next one is production. Actually, it is very important concept. Whenever we are saying anything, whenever we are writing anything, we follow lots of rules. In the similar way, in CFG there are lots of rules are there, which are also called as production rules, and the production is generated on the basis of rules. And the last one is start symbol. It is a non-terminal and it is called as a start symbol, which is represented as capital S, and from where the production begins. And already I have said that the grammar for a language consists of production rule. Just like whenever you are saying something or whenever you are writing something, you follow some rules, grammar. In the similar way, each programming language follows its rules, and CFG also consists of number of rules, and which is called as production rules. What is the meaning of derivation? Okay, in the derivation process, suppose you are solving some sort of problem, you are deriving something, then there are two main important aspects. One is left side operand or left side entity, and next one is right side entity. The left side is derivated by using the right side elements. It means that in derivation process, two elements are present. One element is called as left side element and the next one is called as right side element. In the right side, there may be number of non-terminals. Then the next one is, a derivation basically is a sequence of production rules in order to get the input string. During parsing, we take two major decisions: deciding the non-terminals which is to be replaced, deciding the production rule by which the non-terminal will be replaced. Actually, whenever in the parsing, the main important job of the parsing is to generate the parse tree, okay, according to the predefined grammar. And in order to generate the parse tree, it uses the derivation process. And in the derivation process, the two important decisions the parser has to take, those are deciding the non-terminal which is to be replaced. It means that which non-terminal will be replaced by which production rule and which production rule will be used for the non-terminal, because there are lots of non-production rules. It is very important one to decide which non-terminal to be replaced with production rule. We can have again two different type of option. First one is leftmost derivation and the second one is rightmost derivation. If the input is scanned and derivation process is going from left to right, then it is called as leftmost derivation. And if the input is scanned and replaced from right to left, then it is called as rightmost derivation. It is very simple one. It is then the strings are derived from the start symbol by repeatedly replacing a non-terminal, initially the start symbol, by the right side of the production for that non-terminal. It means that the job of the parser is to generate the parse tree, but the process is that it takes one symbol, that is the start symbol at the first point, then it puts some sort of production rule and start the derivation process. Okay. It means that at each step it again derivate in a continuous process till we will get our final output. Now I am taking one example. in which we will see how the parser work by using the production rule. In any programming language there are lots of production rules, and it is the job of the parser to start from the start symbol, implement the production rule and derivate the next level, and at the final end it will generate the parse tree. Let us start. Let the example is here. Suppose the production rules for the grammar of a language are S derives CAD, A derives BC and A. Okay. In this way number of production rules will be given to you, and according by implementing the production rule one by one you will generate the parse tree. Let the input string is CAD. Our task is to generate CAD by implementing the production rule. At the first step, what we will do? Now, the parser attempts to construct the syntax tree from this grammar for the given input string, and the string is, the last one is CAD. Okay. Here the string is CAD. By using the production rules one by one, the parser tries to generate the parse tree for CAD. Then in the first step, we will start from the start symbol. Always the start symbol is A, it is the first step, and in the second phase we will just derive S by using CAD. Okay. And here actually we need to generate the string CAD which is in small letter A, but here CAD is A is capital letter. That is why the production rule A, B, C, stop. Now we will implement the second production rule, which is A derives BC, but when we implement A derive BC, it is not suitable, because here we are generating the string CBCD, but we need only CAD, which is not, it is not our required string. So here we will discard this one and we will apply the next production rule. The next production rule is A derives A, and here we are getting CAD. Now the string CAD is produced. Actually there are number of different types of parsing techniques, but if we will categorize all the parsing techniques into two mainly broad categories are top down parsing and second one is bottom up parsing. These are the two main different categories of parsing, broad categories of parsing. Actually in case of top down parsing, in any programming language there are number of different approaches we are using. Basically some programming languages are based on the top down approach, some programming languages are based on the bottom up approach. The same concept is used by parser here. In case of top down parsing, the parser generates the parse tree, but here it starts from the start symbol, then it will derive the next level by implementing the production rules, and it at the end when it will reach at the last level and when the input string is generated. Okay. But in case of bottom up approach, it is just reverse of the top down approach. It starts from the leaf level and it goes step by step up, and it ends when it will reach at the starting level or starting point, that is S. In this way the two parser perform the operation and generates the parse tree, but the way they are doing the job, that is different. In the next session we will discuss in detail about top down parsing and bottom up parsing. I hope you have understood the basic concepts of parsing, what is the meaning of parsing, what is CFG, and how the parser derives the parse tree by using the production rule, and the starting symbol is S here. In any problem you will start from S and you will use the production rule one by one. Whenever any production rule is not working, then you will implement another one. Here we are using recursion, here we are using backtracking, number of things. In this session already we have discussed little about introduction to parser. In the next session we will discuss the different types of parser. If you have any doubt, then write to me in the comment box. Thank you so much for watching.